Did you find a calculator? Let me loan you one. It says, explain why 9 belongs to 5 number sets, but negative 9 belongs to only 3 sets. You know what? Let's get clever. Let's go dunk. 9, negative 9. What does 9 belong to? Start with the innermost one. It's natural, because you can count it on your fingers. And anything that's natural is automatically inside all of the next ones. So if it's natural, it's also a whole number. It's also an integer. It's also a, oh, what was the weird symbol for rational? We couldn't use the letter R because real took up the letter R. Q. Why Q? We said quotient. It really means that you can write it as a division question, as something over something, as a fraction. So it is a quotient. It is a rational number, and it is part of the real number. Yeah, it does belong to 5 sets. What does negative 9 belong to? Okay, now this says explain. Here's my explanation with a minimum amount of work and maximum bang for your buck. I'm going to write n, comma, w, comma, I, comma, q, comma, r. And to show why 9 belongs to 5 and negative 9 only belongs to 3, I'm going to go, There. Does that show clearly why it doesn't belong to 5 and only belongs to 3 of them? That's a pretty good explanation. The crossing out. Say, they belong to these. So we've tried to label or categorize numbers. Now we're going to take a bit of a tangent. Well, no. We did talk about which types of numbers were irrational, which type of numbers were rational. You awake? You alive? You're not looking at your phone or something like that? Studying your arm? Thinking about getting a tattoo? Don't. Yeah. I was going to get like a pi symbol. Ooh, okay, maybe. Nerd tattoos. Square roots. I mentioned this a bit before, but it bears repeating. All positive numbers have 2 square roots. Why did I say all positive numbers, by the way? Let's come back to that in a bit. All positive numbers have 2 square roots. One is a positive number and one is a negative number. What's the square root of 16? Well, technically 4, because 4 times 4 is 16, and technically negative 4, because negative 4 times negative 4 is also positive 16. When we use that symbol there, what I'm also saying, Brianna, is I only want the positive answer. That's what that symbol means. It means, oh, and by the way, give me just the positive answer, please. Do you remember what we called the positive answer? I used this word a couple lessons ago. What is the positive square root? It's the, and it also begins with a P. It's a word that begins with the letter P and means the main thing. We call it the principal root. Okay? The square roots of perfect squares are blank numbers. Let's see if we can fill in what goes in here. What's the square root of 9? 3. What's the square root of 10? Square root of 10. Try it on your calculator. Rational or irrational? Look at that decimal. Irrational. Okay, here's what we have. Square roots of perfect squares, they are, if they work out evenly, they're rational numbers. Otherwise, they're irrational. So, next page. Square roots of 16 are what and what? However, if I wrote this, that's true. You don't need to give me a negative one. That symbol there says, oh, by the way, I know this. Give me a positive one, please. What if the number is not a perfect square? What if it's a non-perfect square? Well, these are going to be irrational numbers. Square roots of 17 are root 17 and negative root 17. And whatever the heck that is a decimal. Most square roots are irrational. Example, evaluate the square root of 9 over 16. No calculator. How do you find the square root of a fraction? Square root of the top divided by square root of the bottom. What's the square root of 9? What's the square root of 16? So if I give you a fraction inside of a square root, what I'm really saying, Mark, is it top and bottom, please? Rational or irrational? Rational. You know how I know? Because I'm writing it as a fraction. So square roots. And you need to know where your square root button is on your calculator, too. Cube roots. All numbers, positive and negative, have one cube root denoted by the symbol. Okay, put your pencils down for a second. Look up. When I say find the square root of 25, the answer is 5. Why? What's the square root of negative 25? It's not negative 5, because negative 5 times negative 5 is positive 25. Try it on your calculator. What do you get? Square root of negative 25.
Error.
Now your calculator, everybody get an error?
Yeah. Math error.
Okay, so math error. Did anyone get an answer? What does yours say?
Negative 25.
Underneath the inside a square root symbol? So it didn't give you an answer, it just repeated the question. Is that what you're saying? Okay. Well, the problem here for this to work, Amy, is I would need something times itself that works out to a negative. Now here's the problem. What's a positive times a positive?
Positive.
What's a negative times a negative?
Positive.
Is there any number that when you multiply it by itself, you get a negative answer? But that's not multiplying by, someone said a negative times a positive, but now you're not multiplying it by itself. You're multiplying it by its opposite, not by itself. So let me ask again. Is there any number which, when you multiply it by itself, you get a negative answer? There is. But you know what? It's not real. So we talked last time, I'm not kidding, Tyler, we talked about real numbers. And what I didn't tell you, but I said I think I alluded to it. There are some numbers that are not real, they are imaginary. This number here would not go in the real number set. Yep. You'll have to get the rest of the notes later. This number here would not go in the real number set. We would have to have we would have rational, irrational, real, and then we'd have a third column over here. This is not Math 10, you don't need to worry about it, but it is nerdily cool. If you're wondering what numbers are imaginary, square roots and negatives. Now, how do you know? Because your calculator barfs at you. Although some very good ones will evaluate this, there is actually an answer. Believe it or not, the answer here is 5i. Where the lowercase letter I stands for imaginary. And that imaginary number is the square root of negative 1. It's saying if you could take the square root of negative 1, square root of 25 is 5, and then deal with the negative, put an I on there. About, 250, 300 years ago, a mathematician was playing around, and he just asked himself, what if I could take the square root of a negative number? What if I call it I? And he started doing some math. Turns out, though, there are some real-world problems, some complex circuits in physics and things, where to get the answer, you need to take the square root of a negative number. So they're not quite, he called them imaginary. They're not quite as imaginary as you might think. Our universe is weird. Pencils up. Cube roots. All numbers have one cube root, not two, denoted by the symbol. Hey, Mr. Dewick, isn't that square root? No. What's the key difference? There is a square root symbol there, but what else do you see tucked inside that little square root symbol in front? A 3. That's called the index of the root symbol, cube root. The cube root of a perfect cube is also a rational number. For example, the cube root of 1,000 is 10. Now, if you want to try and find where your cube root button is, we looked at it last class. Find your cube root button. My cube root button is hidden. Whoop. Mine is right there. Try finding your cube root button and try finding that the cube root of 1,000 is 10. If you can't find your cube root button, this is your chance to ask me. Why is the cube root of 1,000 10? Why? Because 10 cubed equals 1,000. So the cube root of 1,000 is 10. The cube root of 8 is 2. Written, cube root of 8 equals 2. Why is the cube root of 8 2? The definition? It's because 2 cubed is 8. Can you take the square root of a negative? We just said that you could not. Can you take the cube root of a negative?
Yeah.
Turns out the cube root of negative 27 is negative 3. You know why? Because negative 3 times negative 3 times negative 3 does give you negative 27. Because you get 3 negatives, which means you have 1 negative left over. Oh, sorry. I should have written this. Is negative 3 written cube root of 27 is negative 3. Whatever. What's the cube root of negative 64? Yeah. Which one? I agree. It's not positive because cube root of 4 would go with positive 64. Cube root of negative 64, only one answer. Negative 4. What's the cube root of negative 54,872? Negative what? Negative 38. Anybody else? Double check.
Yeah.
Yep. I guess that means times negative 38 times negative 38 times negative 38, or negative 38 all cubed, gives me negative 54,872. What if a cube root doesn't work out evenly? What kind of a number is that? Well, what happened to a square root that didn't work out evenly? What kind of a number was that? Be on letter I. Irrational. You know what? Irrational. Cube root of 9. Square root of 9 works out evenly. What's the cube root of 9? Written this way. Give it to me. You know what? Give me the whole screen. 2.08 0083 ... Does it end there? Nope. And by the way, remember, your calculator kind of lies to you. You want more? Okay. What number were we taking the cube root of? 9? 9. And take the root specified by this number. Take the cube root. Oh, heck. Software Max. Calculate. There's the cube root. And try and glance at some of those. I think you'll notice very quickly as you move your eyes through. No pattern. Keeps going. Keeps going. Keeps going. And eventually, I just run out of memory. The software runs out of room. But no pattern. Which means that it is an irrational number. Find the cube root of 300 to 5 decimal places. I don't know. Oh, that's 3,000, Mr. Duick. 300. To 5 decimal places. 1, 2, 3, 4. So I'm going to round off right to there. Jordan, what's next to the 2?
9.
So is the 2 going to stay a 2 or is it going to become a 3?
3.
So it's going to be 6.69433. Now we've rounded off, but we're close. If I go 6.69433 to the 3rd power, I almost get my original question back. Not quite. We've rounded off. But that's the way you can check. There are higher order roots. And this is also where you're going to find a new button on your calculator. The 4th root of 81 is 3. Yeah, turn the page, boys and girls. The reason the 4th root of 81 is 3 is because 3 to the 4th is 81. Now, how the heck do I do that on my calculator if I don't know it? Most of you on your calculator somewhere will have a button that looks like this symbol right here. A little X and a little square root symbol right next to it. See if you can find it. Now, to use it, you have to first tell your calculator which root that you want. Which root do I want in the first example? Square root, cube root, 4th root, 5th root, which root? Type a 4. Press that button. And then what's inside the root? There I get my 3. See if you can find the any root button, and I will help you find it if you can't. So the 7th root of 16384 is 4. Why? Because 4 to the 7th is 16384. What's the 5th root of negative 32? 5th root of negative 32. Now, here is where some of your software may break down. I get negative 2, which is correct, by the way. Who gets an error? Oh, I thought someone said they got an error. Okay. Not the subtraction sign. There's a negative. Show me your calculator in front of it. Bottom row negative? No, that's subtraction. Don't hit subtraction. Let me come look.
Sure.
Yeah, it's an issue. You gotta use that. You're gonna run into problems otherwise.
Oh, okay.
Okay? You can't use this as your negative in higher order math. It's not going to work the way you want it to because the calculator is assuming you mean one thing when you're actually saying, oh no, that's a thing and that's a symbol in front of a number, not a mathematical operation. And it's going to make a difference. Yep. Okay, someone did get an error. Let me pause the video. Continue. So the 5th root of negative 32 was negative 2. Why? Because negative 2 to the 5th power equals negative 32. Find the 6th root of 250. This one won't work out evenly.
2.5.
Alex. 2.5099 what? You know what? ... Right? Rational or irrational, do you think? Irrational. Oh, this is the answer because 2.5099 to the 6th power is pretty close to 250. We've rounded off. It won't be bang on, but it'll be close. Well, I have to find out. $2.5099 to the 6th. Like I said, it's going to be pretty close to 250. 249.999. Rational and irrational numbers. You have to be a bit careful. We won't give you a tricky one like this on a test or a provincial, but I wanted to show it to you as a neat example on your calculator. Try going 1 divided by 998001. What do you get? I'm getting an answer in scientific notation. Are you guys? Some of you may, some of you may not. Let me go to my trusty long digit calculator here. 1 divided by 998001. And let's go Software Max. Here's the answer. And at first, when you glance at this, you might think this is irrational. This one, turns out it isn't. I'll read it to you. Ready? 0 point, listen close. 0000001, 002, 003, 004, 005, 006, 007, 008, 009, 010, 010, 011, 012. See it? 013. Spot the pattern?
Yeah.
Does this terminate? No. Does it repeat? Well, there's the pattern. Turns out it does. But to find where it does, you have to go all the way down to, let me see, where are we? I think I got to go a bit further. Let's see. 978, no, that's not, 8, oh, got to go further. I think right here. Let's see. No, I haven't got it yet. Hang on. Patience, young grasshoppers.
Right next to the yellow 909.
Oh, yeah, here you go. It goes like this. 996. 997. It skips 998 for some reason. 999. And then, Amy, it starts over again, 000, 001. So this one repeats, but to find the repeat, your calculator is not going to carry all that. Calculator's not, Garrett, I'm not going to give you one like that or a test or a quiz. I'm just showing this to you because it's nerdically delicious. It's kind of cool. There are weird numbers out there like that. Okay? What's your homework? I think now that I have done the various roots, we can look at page 211. Because last day I said skip some of the weird roots. Today you know how to do them on your calculator. I think you can do all of number 3, all of number 4, 5 works. 6 works. You have to think about 6. It's being very, very fussy. Number 7, A says sketch a diagram. What they want you to do is sketch your own version of this diagram that we did. And then once you've sketched your own version, they want you to put all of those numbers into the correct section. Okay? Donc. No, I'm not done yet. Number 11. And 14. And we're going to pause there. I'm going to give you about 10 minutes to work on this, and then we got something else we're going to work on in just a few minutes too. Okay?
You already assigned 14.
Yep.